Welcome to Impetus Podcast. Today, we bring you a brand new episode of Expert Speak, where our panelists share powerful insights on everything cloud, data, analytics, and AI.
Hi, I'm Larry Pearson, Vice President and Client Partner at Impetus Technologies, where we specialize in what I like to lovingly refer to as all things data inside of the enterprises. And welcome to our podcast today on the topic of modernizing Hadoop strategies and recommendations. With me on our podcast today is Michael Farnbach, who is an Impetus Principal Solution Architect. Michael has more than 20 years of experience in the broad range of high-performance computing, distributed data architectures, including Hadoop and the cloud, and has been actively engaged during that time advising small, medium, and large enterprises in their evolving journeys to leverage various emerging technical trends. Today, he spends a majority of his time in the area of enterprise modernization, digital modernization, cloud migration, and that's the heart of our topic here today. Michael, welcome to our podcast.
Thank you.
Now, Michael, I in reading your biography and knowing you personally, I know at one point in time Hadoop was a major involvement for you, and it was a modern data architecture at that point in time. What was it about Hadoop that made it modern at that point in time, and how is it viewed today?
Well, that is a really good question. At the time, I've been following Hadoop since 2010. I was working with distributed computing and distributed storage, most importantly, and there were just some problems in that no one could seem to solve. And there was a joke that came from this area that there's only two things that are difficult in programming, and that's naming and cache consistency. Being able to make something consistent where you have locks that can help block out people from working on files that you're working on. The locks become a consistency problem in and of itself. Making sure that everyone's writing at the same place at the same time. I think what really came through from Hadoop, and this isn't a dig on Hadoop, is that it was a simple solution looking for simple problems. It did away with everything that was hard, and the MapReduce algorithm, it sort of has its own built-in consistency into everything. Everyone's going to read at the same time. Everyone's going to shuffle the data between us in the mapping phase, and everyone's going to essentially write at the same time. And when we're going to write, we're all just going to write directly to our own, to the machine that we're at. Hadoop, instead of trying to have everyone write to the same file, everyone wrote to different files, and that was okay. A Hive database can be multiple files across multiple places, and if you look in the directory for Hadoop, you'll see a whole bunch of files there. So the question then became, where can we still make this useful? Are we compromising anywhere? What kind of compromises are we making, and how can we make this useful? And that's been a real fascinating journey in and on of itself. But one of the things that came from it is that its performance was just too slow. Having everything stop and coordinate, especially since every phase of MapReduce means that you're going to write everything down and then read it back again. Just little things like that were just grossly inefficient, and ultimately made the doom of MapReduce and even MapReduce version 2 with all of the memory caching that it was learning how to do inside of Hive and with Tez and things like that. So I think it was seen as something that people could manage. Its modernization was on the operations end, solving, or at least getting, figuring out that we're just not going to try to solve impossible problems anymore. We're going to do what we can and see how useful we can make it. And I think we've driven things pretty well since then. I think that it's still, the algorithms and the basic algorithms in some way or form are still used today with certain accelerations and certain key fixes that may not would be interesting for a cast in and of itself. But but one of the things that did die was that we have evolved, now that everyone is used to doing distributed computing. We've evolved some tools that are much better at process management in distributed computing. The actual computing algorithms in Hadoop are still very valid and still very useful today, but having to set up a whole cluster and especially the file storage, defining the storage across a number of nodes is just not how we do things these days. The model for storage, going to an object storage model, has just made for a much more flexible, much more operations friendly operations model. And same with how the processing management has moved over to Kubernetes, and both of those have I think really been what's killed. The main thing that defined a cluster was Yarn and HDFS, and so when your process management moves to Kubernetes, maybe you can redefine Yarn to be able to do that. Maybe you can redefine HDFS to do that. But for the most part, people have decided that that what we're working with Kubernetes and the application managers on there is better, and the same with just the object storage paradigm directly. So it's in operations. It's in operations that Hadoop, I think, is where it was very simple and very easy. People have since everyone's been able to use it, has gained a level of sophistication where that kind of ease has become cumbersome, and that's kind of the tarnish, and that's where it doesn't look as modern anymore.
Interesting historical perspective. Thank you for that. And I guess what we're really looking back to see is at that point in time, the availability of this open source, distributed and parallel framework allowed us to solve some of those issues at that point of what we used to lovingly call the 3 V's, volume, variety, and velocity. But now, as we've gotten 10 or 12 years into that, there are these other things, and you mentioned Kubernetes, and there are probably some others. What does the cloud do that Hadoop didn't?
Oh, okay. So let's look at it from the standpoint of simple questions or simple solutions, looking for simple problems. Because just as Hadoop did away with file locking and very complex process mapping to be able to make sure that you had points where you'd stop for consistency, because essentially MapReduce would stop for consistency in every operation. That the cloud model does kind of the same thing, right? So the cloud model has a basis that everything is ephemeral. So no single machine owns any particular set of anything. You should be able to bring up an instance of the machine, and it joins the cluster, synchronizes its state with whatever application it needs to be able to synchronize, and then it keeps going. And that is a very that's removing all of the complexity that really that was really an hindrance to the cluster methodologies that were happening before the cloud. So you have things like you can't define a block of resources and then have that block of resources managed independently, because in an ephemeral world, any of those things could really go anywhere in your data center, right? And so um, essentially, when the cloud came from the big cloud operations, where the ones that learned that survival of the fittest, the ones that saw the environment for what it was and worked instead to make the instances ephemeral and just say, okay, where can we go from this? Were the ones that survived and did the best job, and then they all came up to this. All the big, Google came up to this, Amazon came up to this. They both found it and started running in that direction, and really were the ones that took off, because that, having discovered this simpler paradigm, simpler solution, looking for simpler problems, and everything since then has fit inside of that paradigm. With the right management, with the right process management, it's actually pretty easy to deal in this ephemeral state. I think it still hurts a little bit that something can go away and you have to reestablish state when something comes along. But that solution has been working and maturing and getting pretty sophisticated over time. And that I think the best place that is shown is in the object storage model, to where people don't think about how object storage works, where it works. It's name node technically, because you access object storage over a website. Its name node, how you find where everything is at, is essentially the built into the URL. It uses DNS as its top name node, and then works down from there. Uses and that's brilliant, and that's one of those well orchestrated operational keys that's helped object storage be much better than HDFS, for instance.
Interesting. Thank you. Thank you again. As we look at modernization and cloud migration and so forth, everyone's looking for the simplest path and kind of what is the repeatable best practice, and just give me that silver bullet and I'll follow that. Do you see any such tendency here as people plan to migrate to the cloud? And if so, are some of the maybe migration roadmaps that look the simplest also involve certain compromises when they attempt to do that? I'd love to get your perspective on that.
There is an interesting development that's coming from the cloud, and I think in some of our meetings we've talked about this before, but there's even it continues to develop, right? We've talked about how because things go to the cloud, and that becomes sort of a lingua franca, a common platform where everyone is, that collaboration itself becomes the new model. So before, if I had I had my own data center, then I had my own way of doing things, and that's preserved bitterly by a number of people, for good reason, because your strategic differentiator, your IP, might be built in just how how to run your data center. But Google and Amazon have outstripped what anyone individually can do, so much that we all say, okay, Google, Amazon, Azure, Microsoft, go ahead and you manage what's going on. And now my applications aren't locked into my IP or my particular way of doing things. They're now part of a cloud, which, as we mentioned before, has its own sort of inherent operational assumptions that are made about it. And so now that my data is in the cloud, I can share with someone else that's in the cloud a lot more. One of the main differentiators that I pointed out with Snowflake before is that it's multi-cloud, and people like that idea. But another main differentiator that Snowflake has come out with is essentially that if I am a company that sells data, I can, through their sharing, just share and sell my data still. I don't have to worry about building that service. I can use Snowflake as that service. It's the lingua franca, the common dialect now that I can use to collaborate with my data and their data all at the same time, and that's truly powerful. It's that the sense of being able to collaborate and get things done quicker because I don't need my network team to figure out how to work with their network team. Those interfaces, those impedances between those are almost virtually removed, and that is the kind of thing that really makes it really shows where the cloud and how they've built the cloud is gaining momentum and will continue to gain momentum in that ability to collaborate.
Again, a great historical perspective. Do you see people also wrestling with wanting to modernize on-prem and what's going on there, and rather than going to the cloud, and just offer some of your perspectives on that as a thought leader in this space?
Well, there's two things for the on-prem. One is these tools like Kubernetes and MinIO and a number of the application managers are open source, and so being able to change your operations in your data center to work a lot like the cloud, at least have cloud interfaces in them, is very easy to do today, given that you can migrate, given that you can still change these applications that were built in a different paradigm into the cloud paradigm. And that is what we consider modernization, right? So earlier this year, we were working on a survey of what really makes a quantum leap and where are the quantum leaps right now. And really, when you have a quantum leap, it means that you are now accelerating, and you found an efficiency that means that you can take all of your capital, all of your resource capital, and now innovate faster than anyone else is innovating. Innovating is so easy now that you can just iterate your innovations a lot quicker. And this cloud interface, and that's how we measure the modernization of your cloud interfaces, is your ability to iterate now, and your ability to iterate new changes inside of your data center, how to make more changes more quickly. Kind of like the SpaceX model, where you make more and simpler changes and keep trying them out, and that ultimately gets you further and faster than trying to say, let's make sure we make no mistakes in the development phase and get there. Well, in the cloud, it's not necessarily a matter of making mistakes, but it's a matter of being able to see where other people are making mistakes, and being able to make your contribution and your innovation in your own data center, and build on what people are doing, and still own that IP, and still be able to collaborate with people that are around you. But it's going to be that ability to iterate and take what other people are doing and iterate on it. Is still your own ownership.
Yeah, interesting. Again, the flexibility to iterate with velocity, fail fast, all of those types of things certainly help to expedite innovation. So, thank you for that perspective.
Well, if I may, I just want to circle back and point out that really is what we mean by modernization, right? Right. That's if you want to measure modernization these days, that's gonna be your measure. That's why we consider, and what I'm really trying to say is that's why we consider SpaceX more modern, in its approach than Boeing, even just to use an entirely different field to see how this is applying these days. That's just want to make that point. I appreciate your patience with me. I just want to make that point. Is that's really where you measure modernization, and so when cloud comes into your own on premise, it still needs to retain that, and that's going to be basically your design goal and your design paradigms. To be able to work with. And can you do that on premise? Well, you absolutely certainly can. And that's a lot of these tools are open source. The collaboration that's happening between them is open source. And I think that it's definitely possible. The only impedance has always been that you still have on premise all of this legacy that you're still dealing with, and it becomes a migration decision. And where you don't have it in the cloud. The cloud, I think in architectural terms, and the way that it's looked at by up at the sea level, is that's the clean sheet of paper, right? If I move to the cloud, then that's my way of sort of making sure that I cleanse all of this into a modern movement. If I move into the cloud, then I'm guaranteed that it's going to be modern. But that can happen on premise. That can happen with your own data center workers. So I appreciate that. I just want to make sure I got to that point.
Yeah, absolutely. And thank you for the strategic role that you play with our clients, being right at the center of helping them plan for all of this, to innovate rapidly and to migrate to, this redefined digital future that we're all entering into. As we close our podcast today, are there other considerations that you'd like to share with our audience that they should be aware of when transforming to the cloud?
Well, maybe again, just take the opportunity to highlight what I think are the key points, and that is that moving to the cloud is really more, and it should be seen this way. It's really more of an operational change than anything else. The operational change is best understood by understanding the principles that made cloud successful to begin with, and the chief considerations are just going to be migration paths, and that's and migration really is the big key these days. That's what Impetus found 10 years ago, and that's what we continue to work with is the individual paradigm shifts and the individual changes that need to happen to make sure that the logic that existed in the old applications paradigm is working in the new cloud applications and services paradigm, all the same, seamlessly being able to look at that. That's why I appreciate working here. But that's going to be the main consideration. And the more that I've done this, the more that I realize that you want to. It's a process. Being able to learn how to do this migration is a process. It is an understanding curve. It is a learning curve. But when you and there is a really good opportunity to find people who do this and do this often, to find out exactly how to do it, how to do it well. I think the keys to it, I'm trying to give out the keys to the kingdom, and showing how what I've learned from the essence of the paradigm shifts, but how that works from application to application. Finding someone who does this often and does it well, I think is a key to making sure that the migration success happens, and the migration happens. The success is built in from the planning phase all the way to the execution phase, and you have people who are essentially fluent in both paradigms to be able to recognize what the logic really looks like in both, and understand the translation of it from the old paradigm into the new paradigm.
Excellent, Michael. Thank you again for your valuable insights. I trust all of our listeners found them interesting and useful. If you are out there in the listening audience and you do have other questions, you can write to us at podcast@impetus, that's impetus.com. And Michael and his other expert colleagues here within Impetus will be happy to respond to you. And thank you all again for joining, and have a great remainder of your day.
We hope you enjoyed today's episode. Do follow us to stay connected as we help you unravel the data, cloud, analytics, and AI puzzle. You can also look us up on LinkedIn and Twitter, or visit our website, www.impetus.com. Meanwhile, we hope you take good care of yourself and stay safe during these unprecedented times. Thank you for listening, and watch this space for our next episode.